I'm going to go ahead and see if I can help you with this second derivative test, this group work that someone assigned. All right, so let's see. Number 2 is the one that's been giving us a little trouble, and I'll see what I can do to help. I better zoom in just a little bit so you could see. Just a little bit. Okay, so here I go. I'm going to go ahead and find derivatives, and I'm going to use the product rule, u and v. So now I know I'm going to do u prime v plus uv prime when I find the derivative. So here I go. F prime of x equals, hey, this doesn't look too bad so far. 2x times 6 minus x cubed plus x squared. Now here's where some people got hung up. How do you find v prime? First of all, what is v? V is this 6 minus x cubed, right? So walk me through the steps. Bing. And then bing. And then what's the bong? Okay, that's the chain rule. Did it. Well, I got the first derivative. I still need to do the second derivative. And maybe I should simplify this a little bit. What do you guys think? Okay, we'll simplify it a little bit. Let's do this. Let's write it as 2x times 6 minus x cubed. And then let me write minus 3x squared times 6 minus x squared. You guys with me so far? Okay. Let me do this. Let me take out a common factor. You may not have thought of this, but I want to show you that this is kind of a cool trick. I notice that there's an x common to both terms. And I notice that there's a 6 minus x common to both terms. Actually, you could take out 6 minus x squared. You can't take out 6 minus x cubed because this one only goes up to squared. Now, I guess I have to do it and see if you understand what I'm doing. If I were to do that, take out the common factors, what would be left in the first term? Well, I'd still have a 2, and I would still have a 6 minus x, right? Sometimes this is helpful. Sometimes not. I just throw it out there. Okay. Minus, well, I would have 3x, right? That's what would be left. Okay. So I guess if I keep simplifying now, I could say that this is x times 6 minus x squared. And then what would that mess be? Well, it looks to me like it would be 12, right? Well, minus 2x minus another 3x. How about I just write minus 5x? Is that okay? Who's with me so far? All right. So what if I said to you that the first derivative is actually just 6 minus x quantity squared. I'm going to distribute that x through this other piece. 12x minus 5x squared. Right? I'm taking this x and I'm going to just distribute it through that factor. Because I had 3 things to multiply together, decided to multiply 2 of them together. Jamel, you didn't look happy with that. You have a question? What's nice about it now is that it's pretty easy to take the second derivative, well, at least just as easy as the first derivative was. Okay? So let's do it. Let's find the second derivative of x. And once again, I'm going to think of this guy as u and this guy as v and do a u prime v plus a uv prime. Okay? So I guess I better zoom out a little bit so you can see me at work. So here I go. f double prime of x is going to be, and again, u prime v plus uv prime, right? So u prime v would be, well, bing, bing, bong again. 2 times 6 minus x times what? -1. And now I need times the v, so times 12x minus 5x squared. Wow, this is really ugly. Plus u is 6 minus x squared. And now v prime, what's that going to be? 12 minus 10x. How about that? Can I simplify? I sure hope so. F double prime of x equals. Boy, is that ugly, huh? Well, I guess, do you see any common factors? You see how there's that 6 minus x is common? So I'm going to do the same thing I did last time. I'm going to try and factor it out. So let's see. If I take the 6 minus x out of the first term, looks to me like I would have -2 times that 12x minus 5x squared plus, and then I have this stuff left. Well, it would just be one of them, right? It would be 6 minus x times 12 minus 10x. Boy, that's getting really ugly. Sloppy. Sorry, guys. I'll see if I can clean it up. F double prime of x equals 6 minus x times. Now let's see. The part at the beginning here. Oh, you could distribute that -2. You get -24x plus 10x squared. And then what do you get here? Wow. 6 times 12 is 72. 72. And then I get minus 60x minus another 12 is minus 72x. And then here I get plus 10x squared. That's nuts. Wow. Okay. So I really get 6 minus x times, I'm counting 20x squared. Now 72 and 24 is minus 96x plus 72. Holy mackerel. So, matter of fact, I ran out of room. It's 6 minus x times, well, you know, you can take a 4 out of here. Well, 4 goes in each of those, right? So 4. And now I have 5x squared minus 24x plus 18. Wouldn't it be great if that thing actually factored, the 5x squared minus 24x plus 18? I don't see how it factors. I have no idea. I mean, I guess if it were going to factor, it would be 5x and x. And I would need some factors of 18, and I'd have to get 24. I mean, I'd have to try things like 1 and 18, or 2 and 9, or 3 and 6, or... That's all I get, right? Yeah, doesn't work. No, I think we're stuck. So I think the best I can do is like this up here.
Are you going to keep going to get the other points, though? Or?
Well, what am I supposed to do? What the heck was the directions? See, sometimes you get so bogged down, we forget the directions.
We're trying to find where it's concave
Use
up
the
and down.
second derivative. Oh, figure out where it's concave up or concave
We have to set
down.
that equal to 0. Or where
Well,
it's set equal to
okay.
0.
So I know I know where the second derivative equals 0. At least I know one place. Where does it equal 0?
6.
At 6. Isn't that nice? So it equals 0 at 6. So if I'm going to go ahead and do some kind of a second derivative test, what I really want to do, I was not able to factor, unfortunately, but what I really want to do is I want to draw a number line. And I want to put the number 6 on there because I know that f double prime of 6 is 0. And what I'm really wondering is, does it change from concave down to concave up, or what's the deal, right? So if you throw in something on the left-hand side, give me a nice number on the left-hand side. I love 0.
Aren't there other points though that we have to find?
Well, I don't think there are other
There's
points.
zeros?
I don't think so, because, well, we'd have to check, right?
Yeah, I got 2 other ones.
Oh, you did?
Yeah, we did it. We got the whole thing. We
You
just
got
did
the
a
other
really,
2?
really long way. Yeah.
But aren't they used quadratic formula?
No, we used the calculator and found the zeros.
Sweet. Let's see them.
Anxious to know.
Hey.
I don't think that's going to work.
You don't? Let me try.
We got 6.
So up here, you can see that they typed in y1. It looks exactly like what I have for the second derivative right here. Okay? And you can see, well, you can't see very much in this curve. You can see a few lines going up and down, right? But how many times does it cross the x-axis?
3.
3 times, right? Let me try and point them out. It seems like it crosses here, there, and there. And by the way, this last one,
That's 6.
that's 6. But these two, those 2 zeros come from this little mess right here. Wow. Check that out.
Yeah, but how'd you get that answer? Yeah, but how'd you get that equation?
Which equation?
You know, the one that you put in for y1?
It's the second derivative. He put in the second derivative.
I mean, well, that's the second derivative, but it just didn't work.
Okay. If you type in 6 minus x times this trinomial, we ought to get that picture. If Matt did this correctly on his calculator. And if I did my algebra correctly. All right? I guess I could check that. Wow, this one's messy. So, anyways, to show what he did next. This is nice work. He said, all right, here are the answers, 0.93, 3.87, and 6.
How do we find the points of inflection?
Well,
Yeah, I did that after I did the complicated.
they're the things that, they're the points that would make that thing 0. Okay? So I guess one of them we could see right away, but the other 2, if you wanted to get them, you either use the quadratic formula or you use the calculator. So this one's nasty. A little more than I wanted. A little bit. But the thing is, I mean, this happens. You guys had some of those application problems. They give you a profit function. How are you going to guarantee it's not nasty, right? You may have to solve it with the calculator. Okay? So anyways, once you have those 3 points, now he's going to test things in between. Okay? He said if he throws in a 0, by the way, I can test 0 pretty easily. 6 times 72 is what? Positive. So I know that if I try out 0, we are concave up over here. But what Matt found is that once you get past this 0.93, you're going to be concave down. He tested, looks like 1. and he got that this part of it was negative. If I threw in a 1, well, I'm getting positive.
I don't know if you do it or not.
Yeah.
It's
All right.
some crazy work, so that's why.
But it's very nice.
I would check it.
But it's very nice. All right. Remember the back of the page? It's there for a reason.
We're gonna do the plus one.
Okay. So I guess what I'm looking for is, I know that I could have this 6 minus x could be 0, right? But I'm also wondering, what about this one? So there's one of the points where f double prime is 0. But the other one, right? How do we solve that guy? So if I go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, I get 96 plus or minus the square root of 96 squared minus 4 times 20 times 72. Wow. All over 2 times 20. Unbelievable. Who assigned this problem? Let's see.
Mike got a negative actually when you put in 1.
When I put in what?
1. He just did the double f double prime of 1 and got a negative.
And got a negative.
Yeah, that's my. You want the paper bag?
No.
Maybe we'll keep going.
I want to read. Oh, I get a negative also. Hold on. What's 20 plus 72?
92.
92. Minus 96. Negative 4. I agree with you, Mike. So it is going to be negative there. Yeah, I don't know how much more of this part to do. I mean, these are going to be ugly, right?
Yeah, can we see what those decimals are going to be?
All right.
That's not that bad. Like, you're killing me. You gotta know what the decimals are.
Ready? 96 plus, and you can't even see that. It's on the edge. Okay, 96 plus square root 96 squared minus, well, how about I just write 80 times 72, because it's 4 times 20 times 72. Close the square root. That's the numerator, right? Take that, divide by 40, because 2 times 20. I got a 3.86. So my picture so we're going to get 3.87 as one of ours. Or if I basically type the same thing in, but instead of putting a plus, I put a 96 minus the square root. There it is. Divide by 40. It's going to be less than 1. 0.93, is that what we got? Okay. So now, let's draw what it looks like. And so we have 0.93 is a place where it's 0. The second derivative is 0. 3.87 is a place where the second derivative is 0. And 6 is a place where the second derivative is 0. We just saw, and again, let me remind you what I'm doing. F double prime of x is equal to, we said, 6 minus x times 20x squared minus 96x plus 72. And we found that for all three of these points, f double prime of x is 0. And now what I do is I do f double prime of 0, let's say. And I get 6 times 72 is positive. So over here we are concave what? Up. And as Mike Glaus pointed out, f double prime of 1 is going to be 5, because it's 6 minus 1, times something negative. And so it's negative. And that means between here and here I will be concave what? Down. Now I'm going to take your guys' word on it that you guys figured out that this one is concave what?
Up.
And the last one?
Is down.
It is?
Yes.
Okay. Concave down. Wow. Does it always have to alternate concave up and concave down?
No.
The answer is no. You have to check them. Okay? I checked one of them so far, or two of them, so I'm relying on you guys here. Now, we did it, right? That's what the directions said to do. And you had to do the same kind of thing for problem 1. The last part of this group work really ties into what today's lesson is about. Okay? Section 4 of Chapter 5 doesn't have anything new. It's on the second derivative. But what it is using the second derivative. The title of this worksheet, I called it the second derivative test. Okay? So what the thing says is, now see if you can go back, find the critical values of each function, and then use the second derivative to classify whether they are relative maxima, relative minima, or neither. I'd like to help you do problem 2, okay? And then turn you back on problem 1 if you want. So I'm going to keep this picture up here, and I'm going to say what it says is go back and find the critical values. Now wait a minute. If I want to find critical values, which derivative do we need?
First derivative.
Do we have the first derivative?
Yes.
Thank goodness, because I did not want to write it out again. Or have to take the whole thing again. But I guess the question is, what form should I use? Well, I'll tell you that whichever form is the most factored is the best. And so this one up here with the arrows in it, I think that's what I would write. Let's write down that the first derivative we computed earlier was x times 6 minus x quantities squared times 12 minus 5x. That was the first derivative. So now what's helpful, I guess, is that what do I know about that derivative? I know if I want to find its zeros, well, one of them is going to be x equals 0. One of them is going to be 6 minus x equals 0. And one of them is going to be 12 minus 5x equals 0. Does that make sense? So here's a critical value, x equals 0. Another critical value would be x equals 6. And another critical value would be x equals, what's this give me? Right, because 12 divided by 5 is 2.4. Now, do you guys remember the first derivative test? Where you draw the line, where you put 0 and you put 2.4 and you put 6? You guys remember that? Don't do that! Don't do that. That's the first derivative test. There's a quicker way to do it. And what we're going to do is we're going to use the information on the screen about concave up and concave down. Let me show you how this works. X equals 0 is a critical value, right? We know that that critical value is concave what? This is concave up. That means it looks like this. So what kind of critical value do you think we have? We have a relative minimum. You can tell because the second derivative test tells me that. I can see it's concave up there, so I know that if the tangent line is equal to 0, I'm going to have a relative min.
What if the...
Hold on. Let's do 2.4 next, for a reason. What's the deal with 2.4? Concave down. So what does that tell me happens at x equals 2.4? We have a relative, what? Maximum. And now we get to Matt's question. Because what's the problem with x equals 6?
It's the point of inflection.
X equals 6 was a place where the second derivative equals 0, right? F double prime of 6 equals 0. It's a point of inflection.
Doesn't have a better.
And that tells me this is not a relative min or max. It's not a relative min or a relative max. You can't really say anything here. All right? So if someone asked me, why did you do such an ugly example in class? I wanted to show you an example where these different possibilities occur. Okay? And it took a while to get there, but we got it. It's some work. Okay? You can get a relative minimum, you can get a relative maximum, or sometimes critical values aren't either. And so a way of telling would be to do the second derivative test. Now, if you want to do the first derivative test, remember the old way of doing it? First derivative test? Like you did on that homework 2, I think it was, or you could go ahead and compute the first derivative. And you could figure out that, if I plug in a 0 or something, I plug in something negative here, I'm going to get a negative times a positive times a positive. I'm going to get something negative, right? So I could tell you that it's going to be decreasing until I get to 0. Then it's going to start increasing until I get to 2.4. Then it's going to start decreasing until I get to 6. But what happens is it continues to decrease after 6. And that's why 6 is not a relative min or a relative max. And you can use the calculator, or you can graph it to give yourself a little more of a clue. Although I'll tell you something about graphing this one. It doesn't show very clearly with just the standard window. One thing that helps sometimes is this zoom called Zoom Fit. Sometimes that shows you the shape a little better, and sometimes not. We'll see what happens. Yeah, that didn't show me very much, did it? That gave me a huge window. I'll go to Zoom Memory. I'll go back to the one I had before. Yeah, it's hard to really see anything besides the fact that it's going through this 6. But you can see it's coming down, and then it's going to kind of take a little jump like that. Okay. One last question, and then I'm done with this example. Thank goodness, right? We can do some homework.
Yeah, well,
In some ways, this problem is like the homework problems. But in one big way, this problem is different than the homework problems. Because the homework problems, aren't you guys always doing a specific kind, like they'll talk about a price function, or they'll talk about a revenue function, or sometimes there's one about diseases, right? I mean, there's all these different things. And sometimes that's the hard part, is coming up with, well, what function am I actually working with, right? Hey, let's say this was a cost function. Just imagine. And say that, well, we're trying to minimize the cost. So how many things do I produce? Well, maybe I produce 0, right? Or if I'm trying to maximize the cost, maybe I produce 2.4, if you can. I don't know. You guys with me on this? But then I might ask you something, and I say, okay, go ahead, produce 2.4. What is the maximum cost going to be then? How do you find that? There it is. Gina said we put 2.4, but you have to know where to put it, into the original function, right? So you know what? I can actually be smarter than the calculator here. Let me show you what I mean. Let's put these values into the calculator. Into what? Into the original function. The original function was f of x equals, boy, it feels like a long time ago now. It was x squared times, let me do it again. F of x equals x squared times 6 minus x cubed. So for example, I know that f of 0 equals what? 0. And I know that f of 6 equals 0 also. Right? The only one I don't know yet is f of, well, 2.4. Can I get that? Yeah, I can get that. I can go to the calculator here. The easy way to get it, let me show you. I have the graph here. So I'm going to hit second calculate a value. And even though 2.4 is going to be off the screen, I'm going to type it in and see what it gives me as an output. What's it say there? Okay. So f of 2.4 is 268.74. Now, if you want to know why this graph was so ugly, that's why. Because here's what it looked like. If I were going to graph the function, it's like this. It goes through 0, 0. It goes through 6, 0. But then it goes through 2.4, comma, way up there somewhere, right? This is not to scale anymore. There's a relative maximum at 2.4, comma, 268. You guys with me? So that's why this thing took off so much that it was like right against the x-axis. You couldn't even see it. And then it came back down like this. Now the interesting thing, I think, is that it's concave up once you get past 3.87. So it starts doing this. And then it goes to concave down again past 6. So the entire picture looks something like what I drew there on the right. And I hope that helps you a little bit. So if you got things like that, I guess what I would know is there's how many critical values? 2, right? I'll put 1 on the thing. Here's 1 plus the square root of 156 over 6, whatever that is. And over here is 1 minus the square root of 156 over 6. So you'd have to then, pick 3 test points. But it turns out that this one's nice. It goes up, and then it goes down, and then it goes up. And so that's basically the picture we're going to get. Yeah, I want to move on. You do too. Okay, let's do it. So again, section 5.2, number 48. They give me a function they tell me f of x is equal to negative 1.48x cubed plus 27.83x squared plus 199x plus 77.95, and they tell me that x can be between 0 and 20. All right? So my derivative is negative, well, now I got to multiply by 3, right? So I get negative 4.44, right? Thanks for the help, guys. I really appreciate it. And is this 55.66x? And this one's 199. Okay? So there's my first derivative. Okay? And so it says, go ahead and find the critical values using the quadratic formula. Wow. Well, I'm sure you could, and I'm sure you had fun doing it. I'm going to go ahead and use a calculator. So how do I do it? Well, one thing, I wonder if I still have that. No. Some of you guys have a program in your calculator that says quad form. Anyone have that?
I made one.
You made one. That's a beautiful thing to do also. You can, how would you do that? I'm going to show you guys some programming at some point here. But you could basically store that into your calculator, okay?
To take another one of your courses, I think.
Oh.
Where he teaches that sort of.
Yeah, I do it in the summer. So let's see. Negative 4.44. Well, here, let's do this. Let's graph the parabola that is the derivative. So negative 4.44 x squared plus 55.66 x plus 199. All right, I'm going to graph it. Well, there it is. There's one place that it hits. And actually, I don't really care about that one because the critical values, what do they say is the reasonable domain of our model? 0 to 20, right? Let me change the window. Right now it's going from, okay, so let me go from negative 10 to positive 20. Let me try graphing that. There's the other one right there. Okay? So the center is somewhere around here. So it's whatever that is, you know? And I'm going to go ahead and calculate the 0 between, say, x equals 5 and x equals 20. So in between, we found it. What does it give me for an x value? 15.44. Did anyone else get 15.44 using the formula, though? Okay.
I didn't.
15.44. And then the other one was x equals negative whatever. I don't care so much right now. Okay? Now, one thing we didn't know last night when we did this homework, what we know now, is that the second derivative can actually be quite helpful. Let me compute the second derivative. Negative 8.88x. Nice job, Paul. I'm just verbalizing what you're thinking. All right, so plus 55.66, right? So that is the second derivative. And why would I do that? Well, for example, it might be a good idea to take this and put it in the second derivative. 15.44. Now that would be negative 8.88 times 15.44 plus 55.66. And I don't care what it equals. All I care about is I'm looking at this piece, and that's negative, right? That's negative. And this is positive. But that's a lot more negative than that is positive. So f double prime is going to be negative. Now what does that tell me about the critical value?
Relative max.
We are concave down, so the picture is like this. So that tells me, what do we have here? A relative max. Now, part A is done, basically. Part B says, and this is the hard part, isn't it? Interpret what we just computed. This is where I feel like I can help. Okay? I better slow down, though. I better say what the variables represent. That's always how I start to interpret. So x, what does x represent?
Number of years since 1990.
X is number of years since 1990. So basically, this is a model that works from 1990 to 2010. Right? And then what else I have is f of x is millions of dollars for Yellow Page advertising. Is that right? So let's, well, but listen to what happened. This says something historically, doesn't it? We have a relative max at 15.44 what? Years. So if I had to interpret this, here's how I would interpret it. I would say spending on the Yellow Pages increased from 1990 till when? To 2005, and has been decreasing, well, I guess at least until 2010, but let's get serious here, right? Since. I think that should make sense to you. You guys follow what's happening here?
Yes.
Okay? So I feel that this second derivative test makes what I had to do in section 5.2 easier.
What does it mean when it's saying the absolute maximum instead of the relative? In the book it says.
Oh, right. That's a good question. So you asked me, how do I know if it's an absolute maximum or minimum? And remember, this is the closed interval 0, 20. So if you want to know if it's an absolute max or min, you find f of 15.44. What else would you want to find f of? 0 and 20. And one of those three is the absolute maximum.
I had 15, that's why I was making sure that was the right.
So that's the idea. Okay? All right. 12:11 gives me just enough time to collect your homework and pass back these tests. So let's do that.